See, when a body is in motion, at that time I discussed one point, that is position. That is position. So the first thing that should come into mind, that what is the meaning of position of a body? Wherever the body is standing, that can be said as its position. Alright? Wherever the body exists, that can be said as its position. Okay? So, but how to determine the position of the body? What is there any common way that can be accepted universally by whole over the world, or everybody can accept the thing? Suppose for me the position can be with respect to our house. For you it can be from your house. For someone else it can be from their house or from their office, from the hospital or workplace, anywhere. But if we get a unique frame, if we get a unique point to determine or to define the position, so that will be easy for everyone. For example, suppose nowadays all over the world we can see there is specific time zones are there. Okay, like Greenwich Mean Time, you know that at 0 degree. 0 degree what? At 0 degree longitude, Greenwich Mean. So that is the reference point for all other time frames. If you set Indian clock time, you will see that plus 5:30 is always given there. Alright? So here, position, if we determine position, then we have to choose some set of references. And this set of reference we can choose as coordinate axis. Coordinate axis. Do you know what is coordinate axis? Yes, you all are aware. In class 10, you may have studied coordinate geometry, and you may have seen that two axes are there, one x-axis and one y-axis, and here you may have seen the values were represented starting from origin. This is origin. Okay. Now this is rectangular coordinate system, but this is two-dimensional rectangular coordinate system. This is 2D rectangular coordinate system. This is 2D rectangular coordinate system. Here in class 11 we shall encounter with 3D rectangular coordinate system. Okay, this is x-axis and y-axis. Now if I go for the 3D, you can see here x-axis, y-axis and z-axis. See, no matter you take it as x or this one x. Suppose if I can take this one also as x, no problem. I can take this one as y. There shouldn't be any kind of vision. This one will be z. So you can change it, no problem. Okay, here you are having your introductory knowledge, your basic knowledge, so you can just make it up mind that yes, this can be the axis. 3 axes are there, 3 different names are given. Okay, now this is the origin. Here this will be the negative direction of x-axis, this is going to be the negative direction of y-axis, and this is going to be the negative direction of the z-axis. Okay, so this is the rectangular coordinate system. Now if I denote one point at any place here, suppose I am taking one point here. Okay, so this point will have a specific position. See, it will have some specific position, some from z, some from y, even somewhere at x. It is so simple. Like suppose if I am just taking one pen and I am telling you the example how to find the coordinates. See, see, I have here one pen, one sketch, and here one marker. Alright, I am taking it like this. No problem. All are at 90 degree with each other. You can see, have a closer look. No problem. See, here this one can be considered as x-axis. This is with at 90 degree with y-axis, and this is z-axis, which is also at 90 degree with all of these. Now, if I take one point here, if I am taking one point here, see my fingertip. So this point has some dimension at z-axis also, some point at z-axis. It will also have some point in xy plane. This is xy plane. This is xy plane. So xy plane has one point of y here, x here, and this comes to be here. So xy is also here, z is also here. So finally you can say that Finally, you can say that this coordinate has a three-dimensional coordinate, that is x, y and z. So we can represent this one. Okay. Now if it changes its position from here to here, so again you can see this, it is going from one place to other, this point, it is changing its coordinate. So you can say that particle is in motion. Okay. Alright. See. So this coordinate x, y, z is denoting the position of the particle or the object. So you can consider it like that. Next thing, what we have to see now. After position, we have to know about reference point. Now, this position, just a minute, it's quite hot today. Okay, alright. Actually, it's sweating very much. It's too hot today, and fan is also not working well. Voltage is quite down. Okay, alright. Let us concentrate here. See, coordinate axis, and here this is the point. Now, to define this position of the particle, we need one reference point. One reference point. That reference point can be origin. With reference to origin. Now, I am giving one example. Why reference point is necessary? Why reference point is necessary? See, suppose you are at your home and you have to go somewhere. Now, your parents may ask, where you have to go? You will say, here only. Just here only. Nearby. पास में ही जाना है. कितने पास जाना है? तो पास में ही जाना है. ये रेफरेंस कहाँ से है? पेरेंट्स के लिए अंडरस्टूड है कि पास में जाना है तो घर से पास जाना है. दूर जाना है. घर से दूर जाना है. कहाँ जा रहे हो? चलो आज मैं इलाहाबाद जा रहा हूँ. ये तो बहुत दूर है. दूर कहाँ से है? ये रेफरेंस लेना है. ये रेफरेंस आप ले रहे हैं. कहाँ से रेफरेंस ले रहे हैं? अपने घर से रेफरेंस ले रहे हैं. किसी पोजीशन से रेफरेंस ले रहे हैं. डिस्टेंस कभी भी किसी पोजीशन, जब कोई एक पोजीशन आप जानेंगे फिक्स पोजीशन, तभी ना वहां से डिस्टेंस मेजर करेंगे. ऐसा डिस्टेंस मेजर होगा नहीं. तो सिंपल सी चीज यही है कि रेफरेंस पॉइंट कोई एक फिक्स पॉइंट होगा जिसके रेफरेंस में हम सारे ऑब्जेक्ट की पोजीशन डिनोट कर सकते हैं, ले सकते हैं. जैसे आप अर्थ की बात कर लीजिए. जैसे मैं एक अर्थ की बात करता हूं, आप इस अर्थ की बात कर लीजिए. एक इस अर्थ का शेप क्या है? स्फेरिकल. देखिए यही पे काफी लोग गलती करते हैं. स्फेरिकल नहीं है. अर्थ का शेप जियोइड. क्या है? जियोइड. चलिए मैं डीप में नहीं जाऊंगा, लेकिन यहाँ पे आप एक मिड लाइन लेते हैं जो लैटिट्यूड 0 डिग्री लैटिट्यूड, आप इसको कहते हो ये इक्वेटर है. अब इक्वेटर के रेफरेंस में ही आप देख रहे हो कि ये नॉर्थर्न हेमिस्फीयर होता है और ये सदर्न हेमिस्फीयर हो जाता है. रेफरेंस है. ये इक्वेटर क्या है? रेफरेंस है. तो इस तरह से यहां भी 3 डायमेंशनल कोऑर्डिनेट सिस्टम में ओरिजिन क्या हो जाएगा? रेफरेंस हो जाएगा. तो अगर ये पॉइंट ऑफ रेफरेंस हो जाता है, ये पॉइंट ऑफ रेफरेंस हो जाता है, तो पॉइंट ऑफ रेफरेंस कहां लाई कर रहा है? वो फ्रेम ऑफ रेफरेंस हो जाता है. अच्छा चलिए, पॉइंट ऑफ रेफरेंस और फ्रेम ऑफ रेफरेंस आपको हम समझाते हैं मोशन का एक एग्जांपल लेकर. फॉर एग्जांपल, if you are present in the bus and the bus is moving, you are sitting in the bus and bus is moving, you will find anything which passes by, it seems that is also moving. For example, you are sitting, bus is moving into the east direction, and now bus is moving in the east direction and some other vehicle is moving in the west direction. You will find that speed of that vehicle is very fast or very high. Why? Actually the vehicle is not moving very fast. Your speed is also added to the speed of that vehicle. Not in particular, but when you see with reference. Okay, for example, suppose if you see sun, so sun is seen in the frame of which reference? In the reference frame of sky. Moon is seen in the reference frame of sky. Someday morning, you just when you wake up at morning, at that time in summer season, the position from where sun rises, okay, that is different from the position of the sun in winter season from where it rises. Okay, that is different. But this difference in position is seen with reference to some objects. Okay, okay. Let me tell you one more example about reference frame. See, you are saying I am moving. You are saying I am moving. Okay, this motion is in the reference frame of this wall. Suppose if the wall was also moving, then the motion of wall along with me, okay, can be seen with reference frame of any other object. Okay, one more example I am giving. See, I am telling just some examples so that you can understand the concept well about reference frame, reference point. Okay, see, you are sitting in a bus with your own friend. Bus is moving. What do you feel? Your friend is moving or not? Yes, it is obvious. Your friend is also moving. You are also moving. But what do you feel? When the bus moves at that time, your friend and you both are at rest with respect to each other. Both are at rest with respect to each other. But any friend comes to bid you bye outside the bus and bus starts moving. What will that friend feel? That bus is moving, you are moving, but the friend is at rest position. The friend who is outside the bus will be at rest position. You are watching him. That is with reference frame of the road. That he is in rest position. And when you watch your friend, so with reference frame of the bus, your friend is at rest because you are also moving there. So this concept is very logical, and whatever in the universe is present, everything is in motion, you can say that. Alright, so you got the point to understood about point of reference and position and frame of reference So frame of reference here is coordinate axis. Frame of reference is what? Coordinate axis. Alright, now I shall tell you about path length. This position is clear, I think. You have understood well about the position. Now about path length. Let us see. Along with path length, we shall understand about displacement also. Okay? So here